Take the number -1. Now try to find its square root. There's no number on the entire number line, positive or negative, that multiplies by itself and lands on -1, because two negatives multiply into a positive every single time. For centuries, that was the end of the conversation. The square root of a negative number wasn't a hard problem. It was treated as proof the question itself was broken. Here's the part that should mess with you a little. The mathematician who first wrote this number down on paper hated it. In 1545, Girolamo Cardano, working through the formula for solving cubic equations in his book Ars Magna, ran directly into the square root of a negative number and couldn't avoid it. He called the whole exercise mental torture, described these quantities as sophistic, and concluded that working with them was, in his own words, useless. He wrote down the first known imaginary number in the history of mathematics and immediately told everyone not to bother with it. 27 years later, in 1572, an Italian engineer named Raphael Bombelli did something Cardano never attempted. He actually worked out real rules for how these numbers behaved, how to add them, multiply them, use them consistently, in a book simply titled Algebra. Bombelli's rules were correct. They still are. Nobody believed him. Buckle up, because the insults only escalate from here. In 1637, René Descartes, yes, the same Descartes who rejected negative roots as false, coined the actual name we still use today. He called them imaginary numbers, and he meant it as an insult, a way of saying these values don't correspond to anything real. They only exist in the imagination, the way a unicorn exists in a story. The name stuck permanently. 400 years later, we're still calling a fully legitimate branch of mathematics imaginary because one annoyed Frenchman needed a word for fake. For the next century, imaginary numbers lived in an odd limbo. Mathematicians kept running into them while solving real equations, kept finding that using them produced correct final answers, and kept insisting they didn't actually exist. In 1748, Leonhard Euler gave the concept its modern shorthand, the symbol I, and he did something else almost nobody saw coming. He discovered that I connects two things nobody had any reason to think were related: exponential growth and circular motion. His formula, e to the power of I theta equals cosine theta plus I sine theta, quietly contains one of the strangest single facts in all of mathematics. Plug in the right value, and e to the I pi plus 1 equals 0. 5 of the most important constants in mathematics, tied together by the imaginary number everyone still assumed was fake. Even that wasn't enough to settle it. Imaginary numbers had a use, clearly, but no home. Nowhere to point and say that's what one physically is, the way negative numbers finally got their location on a number line. The fix, when it came, was almost embarrassingly simple. Instead of one line, use two. In the 1790s, a Norwegian surveyor named Caspar Wessel worked out that imaginary numbers could be plotted on a second axis, perpendicular to the familiar number line, turning every number into a point on a flat plane instead of a mark on a single line. Wessel published it. Almost nobody read it. It took until 1806, when a Swiss bookkeeper named Jean-Robert Argand independently published the same idea, and then Carl Friedrich Gauss lending his name to it decades later, before the picture finally caught on. Once imaginary numbers had a plane to live on, imaginary stopped functioning as a real objection. It was just an old insult nobody bothered to update. Here's the part people skip past. Calling something imaginary implied it had no physical use, and that turned out to be spectacularly wrong. Every time you plug in a phone charger, alternating current is being described using imaginary numbers because the relationship between voltage and current in an AC circuit literally requires a second dimension to represent correctly. Engineers call it impedance, and it's complex numbered math running quietly behind every wall socket on Earth. Quantum mechanics goes even further. The wave function that describes the actual state of a particle isn't just modeled with imaginary numbers as a convenience, it requires them. There is no way to write the core equation of quantum theory using real numbers alone. The number Descartes mocked as pure fantasy turned out to be load-bearing for the physical universe. So one mathematician called it mental torture while writing down the first example. One engineer worked out real, correct rules that nobody trusted for over a century. One philosopher gave it an insulting name that never got retired. And one 18th century formula quietly proved it was holding together 5 of math's most fundamental constants the entire time anyone was calling it fake. You made it to the end, which means the exit fee is due. One subscribe, that's the toll. I'm flipping this tablet around like I'm expecting a tip on a bottle of water, and you're paying it in the form of a like. Don't. And I'm assuming your MHC molecules are imaginary, and therefore technically incompatible with mine. Stay wrinkly, apes. See ya.